Okay, thank you so much for the question. We're looking at a differential equation here, and we want to solve. And what's important to notice from the outset is that we've got no x values. All we've got is a differential equation in terms of y. So what's critical here? Well, first of all, we want to isolate this derivative, but ideally also we want to get our dy over on the same side as our y value and leave the dx over here. In the current state, it's not really set up well to do that. So I'm going to make two changes to how this differential equation looks before we try and integrate both sides. How I'm going to do that, first of all, is by taking away 3y from both sides, which leaves me with this equation. What I need to do here is get dy over to the right-hand side. But dividing by dy is not ideal. Instead, the strategy you use here, and this is the important step in all of this, is actually finding the reciprocal of both sides. In essence, you just flip them. So if we flip the left-hand side, it becomes dx over dy. If we flip the right-hand side, it becomes 1 over negative 3y plus 8. Now here, what's starting to take shape is our integration, because we can leave dx there and move our dy over to the right-hand side, like so. Now we're ready at this step to find the integral of both sides, and we're in business. We can integrate. Okay, so starting on the left-hand side, this is implied to be a 1. And if we just integrate 1 with respect to x, that's going to give us x plus c1. On the right-hand side now, this is going to be a natural log integration. But what we're missing here is we need to account for the derivative of the bottom here, below the brackets. So the derivative of negative 3y plus 8 is going to be negative 3. So what we need on the top is a negative 3. To cancel that out, we need to divide by negative 3 or multiply by negative 1/3. And with that in place, we then should be able to integrate. Like so. Okay. So we've got the left-hand side set up. I'm just going to leave that there. Now on the right, leaving 1/3 out the front, that's just going to be the natural log of the absolute value of the bottom of that fraction plus c2. And what we can do at this point is we've got a c value on the right-hand side, we've got a c value on the left-hand side. Because these are just random, like a random constant number, we don't know what it is. We can't account for what it is. And so what we can do is we can just consolidate that into one constant. You could say, okay, well, let's subtract c2 from both sides. In that case, we just get c1 minus c2, which just gives us another unknown number. So I'm just going to consolidate that and say that, therefore, x plus c equals negative 1/3 ln of the absolute value, negative 3y plus 8. Okay, and now we've got to free up this y here. And that will take a few steps, but essentially we want to convert it to an exponential. First step of that is getting rid of our scalar here. And I'm also just going to move our natural log over to the left-hand side. So we have, actually no, I'll leave that. So we're just going to multiply by negative 3. Like that. Just gives us our ln over here. Beautiful. Now we're at the stage where we need to convert it to an exponential. So I'm going to write that as e to the power of everything on the left equals everything that was inside the brackets. All right, and final steps rearranging here. We need to, I'm going to firstly write our y expression on this side, and I'm also going to subtract 8 from both sides. Alrighty, and now I'm at the stage where I can divide everything by -3, which the negative will flip the sign on these. So instead of being e minus 8, it'll become 8 minus e. That's okay. And then the 3 will just go on the bottom. And then the last thing we can do here to tidy this all up is we could say that let a equal e to the power of -3c. What that allows us to do is just tidy this up. E to the power of -3c again is just some constant number. We don't know what it is, but it might be cleaner to just represent this as a scalar multiple of that actual exponential function. And so how we would represent that then is just we've actually set up our condition statement. Now we put it in. So y equals 8 minus, there's our a, times e to the -3x over 3. And I think that would be our answer there.